In lesson 29, we're introduced to negative exponents. This is probably the first time that you've seen this. And a negative exponent does not mean that any number is negative. A negative exponent simply means the reciprocal. So reciprocal, remember, is like a fraction when you flip it. So x to the negative n is equal to 1 over x to the n. Here are a few examples. 3 to the negative 4 means 1 over 3 to the 4. It's flipped. It's the reciprocal. 7 to the negative 2 means 1 over 7 to the 2. And if you begin with the negative exponent on the bottom of a fraction, it simply will flip out of that and just be 5 to the regular 8. 6 to a negative 3 is equal to 1 over 6 to the 3. So a negative exponent means reciprocal. 3 to the negative 2 means 1 over 3 squared. And then now we can just do the math. 3 squared, 3 times 3 is 9. Our answer is 1/9. Now here's something that often gets confused. Some students want to make this a negative. Do you see how it's not a negative number? Because the negative exponent means reciprocal. It's the flip of the fraction. So go ahead and turn the page. This next example, we begin with the negative exponent in the denominator of the fraction. So what's that going to do? It's going to flip it up and make it positive. And 3 cubed is 27. Let's do a couple more. Negative 3 quantity to the negative 2 is the same as, is defined to be 1 over negative 3 to the positive 2. And then now we have to take care, this means negative 3 times negative 3, which is a positive 9 or 1/9. So I would recommend that you look at these two examples very carefully. Negative exponents do not give you negative answers, but you can have a negative exponent and the base is also negative, so then you have to take care of that and just be conscious of that. All right, we learned a couple weeks ago the product rule for exponents. If you have x to the m and you multiply by x to the n, we simply add those two numbers together. Well, the same is true when we are combining our like bases. So here we have x to the 4 and x to the negative 2. Since they both have a base of x, we simply add those exponents. So 4 minus 2 would give us 2. And then we look at the m's. We have a negative 5 and a positive 2. When we add those, we get a negative 3. And for now, we can leave this expression just like that. Let's take a look at another one. Look at all the, we're going to go in alphabetical order. Do you see how we have x, y's, and z's? Let's take the x's first. We have a negative 2, a 4, and a 1. 4 plus 1 is 5. 5 minus 2 gives us 3, x cubed. Then let's go back and take a look at the y's. A negative 1 and a positive 5 give us a negative 6 and positive 5 give us negative 1. And adding up all the z's, we have a 1 z to the 1 here and z to the 5. 1 plus 5 is 6. So this would be your final answer there. Here is another definition, and the definition is anything to the 0 is equal to 1. So we can't have 0 to the 0. So if x is any real number that is not 0, then that thing to the 0 is equal to 1. So let's take a look at how this works out in some situations. For this example, 29.6, we're looking at this problem. So we look at our x's. 2 minus 2 gives us an x to the 0. 5 minus 2 gives us y to the 3. This is not quite simplified. If you have anything to the 0, that's equal to 1. So y cubed times 1 is just y cubed. And I will let you go through the other examples here. Anything to the 0 is 1. In example 29.7, if we use the distributive property, and we learned this just today, the distributive property, this has to be multiplied by that. Anything to the 0, we're just going to ignore because that's a 1. And when you multiply by 1, the number is just the same, right? So we have x to the 5th, no more x's here, so we would have x to the 5th. Y to the 0 goes away. Z times z to the 0, 1 plus 0 is 1, so we have a z to the 1, and then we have a p to the negative 3. Let me see where the answer is for this one. Okay, here it is all the way down here. X to the 5, z to the 1, p to the negative 3. Going back up here, now we're going to multiply this term by this term. So we have 5 minus 5 gives us x to the 0. That means that we would not have any x terms, x variables in that term. We have y to the 0 and no more y's, so we don't have a y either. Then we have z to the 1 and z to the negative 1. 1 minus 1 gives us z to the 0, which again is just 1. Then we have this 4, right? So it's 4 times 1 times 1 times 1, which is just 4. So anything to the 0 is going to be 1. 2 to the 0 is 1. Negative 2 to the 0 would be a negative 1, because this negative is not raised to the 0. Negative 2 quantity to the 0 would just be a positive 1 again. So make sure that you understand those rules and how they work. Again, I would have you go through the practice. Make sure that you are understanding the rules well before you try the homework. Thank you.